You are a Python developer, given this popular interview question to solve. Given the list nums and a single value called val, write a function to reorganize nums so that all of the val elements are removed or just moved to the end of nums, which means all non-val elements should be in the first portion of nums. Then the function should return the number of non-val elements. The self-taught naive developer might try to loop over the list with a for loop and check if the current iteration is equal to val and remove that element. By the way, it's best to use nums.copy in the for loop to avoid unintended effects from altering nums while iterating over it. But the problem with the copy method is that you've doubled the amount of memory used, making the space complexity big O of n, and we can do better than that. So maybe the naive developer will try using a while loop, simply removing val as long as it exists in nums. This way we get the same effect without doubling the amount of memory. But either way, both approaches actually have a time complexity of big O of n squared, and that'll get you kicked out of the interview fast. This is because the remove method actually has a worst case complexity of big O of n, and looping over a list with for or while is also big O of n, so you get n times n. A better developer will implement their favorite overused tool, the list comprehension. We'll simply reassign nums to be all of the values in nums that are not val. This approach is much better with only big O of n in time complexity, because we're only looping over nums. But I bet you didn't know that list comprehensions always create a new list in memory, therefore making the space complexity big O of n, so you're gonna stay unemployed. The Chad optimal developer will use a pointer approach to modify the list in place. Initialize a pointer to 0 and simply loop through nums and move any non-val elements to the pointer at the start of the list, and then increment the pointer to the next position. This means all non-val elements will end up at the start of the list. Also, the pointer precisely represents the amount of non-val elements, so we can simply return pointer. This has a time complexity of big O of n, like the list comprehension, but also a space complexity of big O of 1, since we didn't duplicate anything. Congrats on scoring the interview.